Hello, welcome to Soft Papers channel. I am Godfrey. In this video I'll be solving Cambridge AS Physics. Our topic is density and pressure. November 2019 exam series it is. I encourage you to consider doing your revision topic wise. Read a given topic and come attempt the questions when the content of that topic is fresh in your mind. This way you will be able to get the most out of the topic. This is a sure way of getting your A star if that is your objective. If you have not yet already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new topic. Well, I will wish we get started. This is how you will be able to identify from what paper and what number is the question that we are tackling here is from. This is 9702. This is the code for physics A level. The paper that you are doing is paper 1-1. This is question number 11. November 2019. So if you need to refer, use this to be able to know which question we are tackling. Alright, let's get started with number 1. An object of weight W. An object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. Alright, we have that information there. Let's see what is the question. What is the ratio? What is the ratio? Density of oil to the density of water. Of course, this is water and this is oil. Density of water is equals to rho W. Let's take it that. We have upthrust. When it is immersed, it is acted by a force we call upthrust. Upthrust is weight of the object minus the upward pressure, and we know that weight times the reading of P, which is in water, is equals to density of water times gravity times volume. Okay. That is the upthrust, or acting on the object that is submerged in water. Density of oil, let's go to oil. Density of oil is equals to raw oil, let's call it that. And we know that the volume of the object is V, which we have already used there, the same volume. Of course, G is gravity. You can specify that here, acceleration due to gravity. And we know now upthrust, when it is immersed in oil, is still W minus the reading of the Newton meter in oil, which is Q. And therefore upthrust, which is W minus Q, is equals to the density of oil times G times V, the volume of the object. And we can make the density of oil, because we need density of oil and density of water, make density of oil subject here. So density of oil is W minus Q over GV. Okay, and We can also make density of water here subject. So density of water is equals to W minus P over GV as well. And therefore, now we can take the ratio of density of oil to the density of water and say that density of oil divided by density of water, density of oil divided by density of water is equals to, of course, oil is W, this one here, minus Q over GV divided by W minus P over GV, of course, volume of the object. Of course, this will give us W minus Q over GV times GV over W minus P. Of course, this will cancel. What we get is W minus Q over W minus P. And that happens to be the answer, which is right here, D. Question number 2. This question was set on, appeared on paper 1-1, and it was question number 14. So you can have that in mind if you need to refer the mark scheme of the question paper itself. In a large container in an oil refinery, 3 oils of different densities are mixed. No chemical activity occurs. They do not react with each other. We have 3 oils, and they are all of different densities, and they are mixed. The mixtures consist of these measurements here: 1200 kilogram of oil of density that, 1500 kilogram of oil of density this, and 4000 kilograms of density of oil of density this. What is the density of the mixture? When you mix the 3, what is the density? Of course, to answer this question, first find the volume of the 3 oils, of course, of each oil, and then add them together, and then add the volumes together. Add the volumes together to know the volume of the mixture. So for the first oil, the volume is mass divided by density. 1200 divided by 100, this is 110. Then this is going to give us 1091 meters cubed. For the second oil, volume is 1500 divided by 860. This will give us, use your calculator, you get this meters cubed. Then for the last oil, volume will be mass 4000 divided by the density, which is 910. You get the volume of 4.396. If you add all this together, if you add the 3 volumes together, then you should get this is meters cubed, 7.231 meters cubed. That is the volume of the 3 oils. So now we need to find the density of the mixture. So the density of mixture is equals to their total mass. This density is mass divided by volume. So we have 1200 plus 1500 plus 4000, and all of these divided by the total volume of the three oils mixed, which is 7.231. And when you do your maths correctly, you should be getting something like 926.6, which is approximately 927 kilogram per meter cubed. That means the answer is A. It's great you're watching these videos, but remember, you need to practice working out these questions yourself, and that way you will learn the most. And you can get the same paper I'm solving right now from this site, solvepapers.co.uk. This is the site I'm talking about here. This is the site, Solve Papers. I'll need you to go to A-level physics. We are dealing with 2019, but you can find all these other years there. 2019, we are on 2019. 2019 AS. You click there, and you'll find all the topicals that you are dealing with here. You'll find Physics AS topical 2019 November, both multiple and structured, and some solved. You'll also get June, multiple, structured, and solved. Right now we are dealing with November, density right here. I need you to download this, and you can get the rest, all of this, both multiple and structured, by clicking here. You can click here and get all of this at a premium. Of course, you'll get 2019, 2018, 2017, 2016. All of them are available for both maths, A2 and S. We are dealing with AS. AS physics. You can get for chemistry and maths as well. Of course, it's only £10. You can request your parents to help you acquire these papers. You can acquire as many as as possibly as you can, and let's work out this question and get you prepared for your exam. You'll get for both AS structured. We are dealing with multiple choice, so you shall get this, or you can get all of them at a discount. Of course, at a discount you will get a better deal. I also do online tuitions. I have online tuition class at this site. We call it spacademy.co.uk. If you need my help, can always be available to assist you in getting that your standard grades that you are looking for. And this site I'm talking about here is this one here, SP Academy. SP for Soft Papers Academy. Of course, this is the site I'm talking about. You can find time and explore it, but I need you to come to a student guide. If you are a tutor, go here. If you are a student, you can come here and click here for a step-by-step guide for student dashboard. You can also watch this video to get familiar with the online live classes. We offer tuitions, me and my other colleagues, on ICT, mathematics, physics, biology, and chemistry. You can get in touch with us if you need any help at all. We'll be able to help you at the comfort of your house. What I need you to do is come here on the login and create an account. Of course, you register and create an account. Of course, give us the correct email, because we'll send you an email, and you'll need that to be able to activate your account and to be able to sign in. Once you have signed into your dashboard, then you can find a tutor and request for tuition. I hope to be seeing you in my tuition classes. That would be glad to help you out. All right, let's continue with question number 3. This question was on from paper 1-2, and it was question number 13. 4 measuring cylinders are filled with the same liquid. 4 measuring cylinders are filled with the same liquid to the heights shown, to different heights. This is 30, 30, 10, and 10. At which position is the pressure greatest? At which position is pressure greatest? we know that, of course, in liquids, pressure is equals to density times G times height. Okay, so you can see density is the same because the liquids are the same. G is also the same because they acted upon by different. I mean, they are of course the same. They acted upon by the same gravity. Then H is different, and therefore, what will determine what pressure will be greatest will be the height. Of course, you can see A is here, the point that we are supposed to calculate there. So A is only acted upon by atmospheric pressure only from the air. So it's not acted upon by the pressure of the liquid. Then, of course, B is this height. B is at this height here. This is the height at B. Okay. So you, of course, also C will be atmospheric pressure. It will not have any pressure due to the liquid. And D, so you consider the height between D, this point D, and point B, which one is greatest. And you'll find that height for B is greater. Height for B is greater than H for D, right? H for D. Both A and C are out because they are not in the liquid, and therefore the answer is going to be B. B will have a greater pressure. Very well. Number 4. This question number 4 is gotten from paper 1-3, and it was question number 10. Of course, October-November 2019. A solid sphere, which is less denser than water, a solid sphere which is less denser than water is held completely immersed in the water at a few meters below the surface. The density of the water is uniform. The sphere is released. Immediately after release, the sphere rises. Of course, since it is less denser than water, it should come up. It should float on the water. So it is held completely immersed a few meters below the surface of water. So when it is released, it will shoot up. It will come up because upthrust is greater than the weight. Therefore, it will come up. Which row correctly describes the changes in the upthrust on the sphere and the resultant force on the sphere? Of course, upthrust, you know well that upthrust is the weight of the displaced liquid, is the weight of the displaced liquid, displaced water for this matter, right? Of course, the weight that the sphere is displaced, if you take the volume of the water that has been displaced by the sphere, of course, it will be equal to the volume of the sphere, and then you find the weight, find the mass, then convert to weight. That will be equivalent to upthrust. And when immersed, of course, it is tensionary. Okay, when immersed, it is stationary because it is held. It is stationary because it is held down there. Now, in this case, you can say resultant force will be equal to the upward force minus the downward force, right? But both upward force and downward force decreases as the sphere rises, right? I hope you can figure that up. So the upward force will decrease as the sphere rises. So the upward force and the downward force decreases as the sphere rises. As the sphere rises, right? And so the RF resultant force will also decrease. So the upthrust on the sphere will decrease, the appearance of the sphere will remain constant, right? Because it is acted upon by the weight. Appearance is equal to the weight of the displaced liquid, displaced water, which will be constant throughout as the sphere comes up, so it will remain constant, and therefore the resultant force on the sphere will decrease as the sphere comes up, because the resultant force is the upward force minus the downward force. Of course, you remember force is equals to density divided by volume, of course, and therefore what you're going to get here is the answer will be B. Number 5. This was from variant 1.3, and it was question 13. We're told that at a sea level, the atmospheric pressure is 1000 kilopascals and the density of air is 1.3 kilogram per meter cubed. Assume that the density of the air decreases linearly with height above the sea level. Decreases linearly. What is the estimate of the total height of the atmosphere based on this information? Of course, we estimated the height of the atmosphere, right? The height of the estimate of the total height of the atmosphere based on this. Of course, we know that pressure is equals to rho gh, okay? And we want H. So H is equals to pressure divided by GH, okay? We are told here the air decreases linearly, okay? So can make this conclusion since air density decreases linearly, linearly as height increases, okay, at the top of the atmospheric, at the top height of the atmosphere, the pressure of the atmosphere, the pressure will also be very low. Okay, you can also assume that the pressure at that point will be almost zero. So we multiply, because the pressure will be almost zero, we multiply the calculated height by 2. This is what I mean. Height will be equal to pressure of 1000 G 1.3 times that is the density. Actually, this was density here, not pressure. This is density G times 9.81. So if the height will be 7.84 for this kind of pressure, kilometers for this kind of pressure, because we are talking about the height, okay? But this is an estimate. We are supposed to estimate. We know that as you go up, the density of air decreases, and therefore, since the density of air decreases, you would have as well, of course, divided the density by 2. But instead of dividing density by 2, you can multiply this one by 2, the height, and you'll get something like 15.68 kilometers, which is approximately 16 kilometers. So the answer of the total height of the atmosphere is estimated to be 16 kilometers right there. Yeah, that's it. Thank you for keeping me company solving this video. I hope it will be of help to you. Recommend it to your friends once you find it useful to you. Hopefully I'll see you in my next video. Cheers.